Now, good day. Now, at this point, we are going to move to inverse element. Please make sure that you subscribe now our channel. Subscribe now, beg. Don't just view and go. Just tap on the subscribe button. Thank you very much. Now, inverse element. If you want to talk about inverse, what is an inverse? Indices. Inverse is anything exponent negative 1 is an inverse. So if I have 4, I'm going to get the inverse of 4 to be 4 exponent negative 1. If I have 2, I'm going to get inverse of 2 to be 2 exponent negative 1. Yes, now let me give you some small understanding here. Now, if I have 4 multiplied by 8 inverse, you see 4 multiplied, this one is the same as 1 over 4, right? You turn it upside down with the inverse. What are you going to get? You're going to get 1 because 4 will cancel 4, so 1. You've seen 1, right? What is the meaning of 1 when it comes to identity? When it comes to multiplication, 1 is the identity element. So which means that anytime you multiply a number and its inverse, you are going to get 1. That is identity element. So it is like a operation. And its inverses, a is for negative 1, will give us an identity element. No matter how the things give us an identity element. Identity element is what? E. So this is a simple explanation you're supposed to know. Now let me go to subtraction. Let me go to addition. Addition, let's say we have 4 plus, when it comes to addition, inverse of addition is minus 4. And this one gives us 0. What is 0? 0 is the identity for addition. So when it comes to addition, the inverse of 4 will be negative 4. So 4 plus negative 4 is supposed to give us what? 0. 0 is the identity for addition. You see how the thing is? Yes. So what you have to know is that anytime a number operating on its inverse, we are supposed to get an identity element. That is what helps keep you in mind. Yes. So I can say that any number m operating on its inverse, I'm supposed to get 1, which is the range element. Or any element operating on its inverse, I'm going to get identity element. It is also commutative, so A inverse operation A is supposed to give it the same identity element. So it means that A inverse A operating on its inverse is the same as inverse operating on the A, which will all give me identity element. So identity element is also commutative. So this is an inverse. This is how we can find the inverse. So it means that the moment we find the inverse, we need to find the identity element before we can find the inverse. Yes. So let me do some small explanation. Now, let A be the inverse of A. So this one is the inverse of A, where the A belongs to a real number. Where A belongs to a real number. Then anytime we have A operating on its inverse supposed to give us identity element, or identity element A, the inverse operating on the A supposed to give us identity element. Now, which means that A operation, okay, so which means that is A, then continue, A operating identity element or is the same as the identity element operating on the A. All of them supposed to give us an identity element, where the E is also a real number. You see how simple it is? You see, mathematics is about manipulating of numbers, right? Yes. But as a mathematician, you're supposed to be able to define this thing simply without struggle. You understand? Yes. That is why I'm here. I can explain it without struggle. Yeah. You have to be able to explain this one without struggle. Because the thing is that you want to deal with numbers, but this is the actual definition. And this is what we use to do the mathematical model. Yes. So you have to understand these things very well, the concept behind it before the normal calculation. Understanding is different from the knowledge. Don't be interested in calculation, be interested in the understanding. Yeah. Now, let's take some questions. Now, another thing you're supposed to know is that when I have sets of numbers, each number has a different inverse. So inverse is unique. It's unique because my inverse is different from your inverse. You understand? Yes. We can also identify inverse on the table. But let me go through that. I will do that one later. Now let's see. Let me talk about it. Let's take a question like this. An operation. We are coming to solve this question. An operation is defined on a set of real numbers are by now let me take this one by, let's say x operation y is equal to x plus y minus 6. Now it is basically x plus y minus 6. Find A. I'm going to write it later. Find A identity element. Identity element. Now B, the inverse. Now when it comes to the inverse, there can be specific the inverse of something, either inverse of x or inverse of y or inverse of anything. So they can say inverse of anything. I can even say inverse of m. Yes, so when I say inverse of m, it means I have to use m to do it. If I say inverse of s, I have to use x to do it. Now, so let me say inverse of m. Okay, fine. Now B, we are going to find the inverse of 3. So let me guide you through this particular question and let's see what's going to happen. Now, so we have the operation, the definition. We have s operation y is equal to x plus y minus 6, s plus y minus 6. Now what we are looking for here, at this particular point is to find the identity element. So what do we say about identity element? If I have x operating on identity element, it's supposed to give me x, right? Yes. Now so let's continue. S is S, Y is E. S is X, Y is E. So let's substitute. We have X plus Y. Y is E. Minus 6 supposed to give us what? X. I hope this is simple, right? Now let's solve for the E. Now it means E will be equal to X minus X plus 6. This one will go, this one will go. So which means our E is equals to 6. So therefore it means identity element. Is equals to 6. Now let me go to B. B says we should look for inverse of m. And inverse of m is exponent negative 1. Don't forget it. Now so inverse of m, it means m operating on its inverse supposed to give me an identity element. Don't forget this place is 6. M operating on its inverse supposed to give us an identity element. So let's compare to this one. X is now m, y is now m inverse. Let's substitute. So this x is now m plus y is the m inverse minus 6. Supposed to give me identity element, which is 6. Don't forget that the E is identity element to 6. Now let's find m inverse. M inverse will give us what? 6. 6, right? This one will cross over plus 6. This one will cross the equal to sign minus m. So m inverse will give us 6 plus 6 is 12 minus m. This is the inverse of m. We are done. It's very simple. Now let's go to the C. Now this one is C. Let's go to C. Now at the C, we are looking for inverse of 3. Inverse of 3 means that we are looking for something like this. 3 inverse, something like this. Now, when it happens like this, you're supposed to find the inverse. Since we have an expression for the inverse, we just have to substitute the value for m inside as well. So we have 12 minus m. M is 3. So this one will give us 9. So the 9 is the inverse of 3. We are done. You see how simple is this? Make sure you like the video, then you share to your friends. Let it be beneficial to other friends. Okay? Bye-bye.